Hi 7th graders, it's Mrs. Trombley with a lesson on section 5.2. Today we're going to look at two things. We're going to look at the perimeters of similar figures and the areas of similar figures. And basically, the perimeter, it's kind of the same thing that you just learned in section 5.1. It says here, if two figures are similar, then the ratio of their perimeters is equal to the ratio of their corresponding side lengths. So you just had the task in section 5.1 of matching up those corresponding sides and simplifying them to make sure they were proportional. Now we're going to use that information to help you identify the perimeter in similar figures. So this says here that the perimeter of, and this triangle ABC just means this triangle right here, ABC, that's how you identify it. The ratio of the perimeter to ABC over the perimeter of DEF. So triangle DEF there. So same thing, we would be comparing AB to DE. So the perimeter of ABC to DEF is equivalent to, I could just match up those side lengths. Or I could match up BC and EF. Or I could match up AC and DF. Those would all be equal. So I'll give you just a little example so you can kind of understand what I'm talking about here. Let's say that, and yes, please write this down. Let's say this is 2, this is 3, this is 4, and these are similar, so I'll give you some similar measurements. Let's say this is 4, this is 6, and this is 8. So I'm telling you, these are similar triangles right here. The ratios of their corresponding sides will simplify to the same thing. So if I compared the ratio of, let's say, 2 to 4, that would simplify to 1/2. What does 4/8 simplify to? 1/2. What does 3/6 simplify to? 1/2. So the ratio of their corresponding sides are proportional. They all equal the same thing. That means yes, they are similar, and it also means that the ratio of their perimeters is 1 to 2. Now what does that mean? Well, take a look at triangle DEF. The perimeter of triangle DEF is 4 plus 6 is 10, and 10 plus 8 is 18, right? So the perimeter of this is 18. If the ratios of their perimeters is 1/2 or 1 to 2, that means that the perimeter of ABC is 1/2 of the perimeter of DEF. So if the perimeter of DEF is 18 and the perimeter of this is 1/2 of that, what should the perimeter of this one be? What's half of 18? It's 9, right? Well, 2 plus 3 is 5, and 5 plus 4 is 9. So basically, being able to identify this lets you figure out the perimeter of a shape without counting up the distance around it. If you know the perimeter of the second one and you know the ratios of their perimeter, it allows you to figure out a measurement on the first one. So when I say the ratios of the perimeter is 1 to 2, that means that this first triangle, its perimeter is half of the second one. Alright, we'll do some more examples. I know, it's kind of a heavy little topic here. We'll get through, we'll do plenty of stuff in class. Alright, so this first one, this is all about finding the ratio of the perimeters. It says find the ratio from A to B, because it would be a little different if we went from B to A, so pay close attention to that, of the perimeters of the similar rectangles. Now up here it says that the ratio of the perimeters is equal to the ratio of their corresponding side lengths. So I'm going to show you how easy this is. 4 and 6 correspond, right? And if I want from A to B, I'm going to put the 4 on the top, which is A, and the 6 on the bottom, which is B. I need to simplify that always. So the GCF of 4 and 6 is 2. 2 goes into 4 twice. 2 goes into 6 3 times. That's your answer. That's it. So the ratio of the corresponding sides is equal to the ratio of the perimeter. So all you do is match up the corresponding sides and simplify. And this means that the perimeter of A is 2/3 of the perimeter of B. So if you knew the perimeter of B, you could multiply it by 2/3 and get the perimeter of A. Alright, let's try something with just words and without a picture. And remember, it's always a good strategy. You could draw a picture for any of these when you see just words. But picture this. The height of figure A is 9 feet. The height of a similar figure B, so we know they're similar, is 15 feet. What's the ratio of the perimeter of A to the perimeter of B? Now, I want to go from A to B, and it says that the height is 9, and here it also says the height is 15. So those match. I just gave you corresponding sides without a picture. For A to B, the height of A is 9, the height of B is 15. So that's the ratio of the corresponding sides, which is also the ratio of their perimeters. Simplify it. GCF is 3. 9 divided by 3 is 3. 15 divided by 3 is 5. And the ratio of their perimeters is 3/5. That means that if I multiplied the perimeter of figure B by 3/5, I'd be able to find the perimeter of figure A. Alright, let's try another one. This one's a little bit trickier here. I'm asking you to find something different. The ratio of the perimeters of two similar figures is 3:5. So right now, I've given you the ratio of the perimeters. I'm not asking you to find it, I'm telling you. It's 3:5. If the perimeter of the smaller figure is 21, what's the perimeter of the larger figure? So now, we're actually going to try to find the perimeter. And you might be thinking, but you haven't drawn me any shapes. How am I supposed to count the number around it? What do I do? Well, I don't know if you noticed this, but this problem is actually quite similar to the problems you had to solve in Unit 3. I give you a ratio, 3:5, so that's two numbers, and then I give you another 21 there, and we're looking for a fourth number. In the past, when you've been given three numbers and asked to find a fourth, what did you set up? Hopefully you just thought to yourself, oh, a proportion, those fractions that equal each other. That's what we're going to do here to find the perimeter of the larger figure. So I know the perimeter of the two smaller figures is 3:5. I'm going to write that as a fraction. And I know that the smaller figure's perimeter is 21. Now, do you see how 3 is smaller than 5? That means the 21 needs to go with the smaller one. That 3 comes from the smaller figure. So here's the perimeter of the smaller one. I need to know the perimeter of the larger one. So 3 to 21 is going to be the same as 5 to whatever the perimeter of the larger one is. Yes, I used P. I can't help myself. Me and my silliness. You know how to solve that, right? You know how to solve it like a champ. Go for it. 3 times P is 3P. 5 times 21, that's 105. Divide by the coefficient of P. Oh, I didn't draw my line. And 105 divided by 3 is 35. That's your perimeter. That's it. Alright, last question about perimeter, and then we move on to area. I know it's not over yet. But I ask you, how does doubling, tripling, quadrupling the side lengths of a shape affect its perimeter? Well, remember in the beginning when I said that similar figures have a proportional relationship going on? Their side lengths simplify to their corresponding sides. The ratios simplify to the same thing. Well, if there's a proportional relationship going on, we said in a proportional relationship that as x doubles or triples or quadruples, then so does y, right? Well, this is that same kind of relationship. So if I double or triple or quadruple the side lengths of a shape, it's going to double, triple, or quadruple the side lengths of the other shape. So in order to answer this, I would just say the perimeter of the new shape would also, so if I have this shape and then I choose to double, triple, or quadruple the side lengths, the perimeter of the new shape is also going to double, triple, quadruple, etc. I'll just throw it right there. And it's because it's proportional. So maybe write the word proportional there. It's kind of the heart of 7th grade, proportional relationships. We've talked a lot about them. Okay, now we're going to look at area. So turn your page. And the area is a little bit different. It's not exactly the same. There are definitely some similarities in this, which is why they're pieced together. But they're not exactly the same. If two figures are similar, then the ratio of their areas is equal to the square of the ratio of their corresponding side lengths. So we're still trying to identify the corresponding side lengths. We're going to find the corresponding side lengths and list those out. But instead of the answer just being that, you have to square it. And with area, don't you square the units? always. So it would make sense. Doesn't it make sense that you'd have to square it? So same thing as before, the ratio of the areas of ABC to DEF, when you find the corresponding side lengths and square them, they're all equal to one another. It doesn't matter which one of the sides you pick to match up, they're all going to give you the same exact answer. So just so you can kind of get an idea of what this means here, I'll just throw in some fake measurements, and you can too. If these triangles are similar, let's say that this base is 10 and this is 5, and this base is 20 and this is 10. So those would be similar. Alright, so what this is saying is that the ratio of their corresponding sides squared is the ratio of their areas. So let's find the area of this second triangle here. The area of the triangle is base times height divided by 2, right? So 20 times 10, that's 200, and 200 divided by 2 is 100. So the area of this is 100 units squared. Okay, so I want to know the area of this smaller triangle based on the information that I have. So here's what I can do. I'm going to take the ratio of their corresponding sides, so I see 10 and 20, and of course simplify that. And now it's saying, so the area of this one isn't half of that. The area of this one wouldn't be 50. That doesn't work. What I need to do first is I need to square this. So that's what this little 2 means here. I take the ratio of the corresponding sides and square it. So I want to square both the 1 and the 2. I'm going to wrap parentheses around that so I know to do that. 1 squared, again, it doesn't mean 1 times 2. It means 1 times 1. You have 2 1s being multiplied. So 1 times 1 is 1, and 2 times 2 is 4. So this is saying that the area of this first triangle is 1/4 of this one. And remember that word of means multiply, right? So if I know the area of this one is 100 and I want to know the area of the first one, I can just take this 100 and multiply it by that 1/4. And when you do that, you end up getting 100 over 4, and 100 divided by 4, of course, simplifies to 25. Let's make sure we're right. Let's see if this actually works. So to find the area of this, you would take the base times the height divided by 2, right? So 10 times 5 is 50, and 50 divided by 2, it's 25. So this actually works. So when you find the ratio of the corresponding sides squared, you're getting the ratio of their areas. If you multiply the area of the second shape by that, you can get the area of the first shape without actually doing any calculations. So if you're missing some pieces, this allows you to find them. Don't you hate missing pieces? You ever get to a puzzle and the last piece is gone? It's terrible, isn't it? My family likes to hide the last piece so we can be the last one to put it in, but we all do that, so we end up missing 4 pieces at the end instead of 1, and we all have to do it at the same time. Sorry, enough about that story. Maybe you'll try it now. Do a puzzle and mess with someone. Okay, so finding the ratio of the areas. First one, picture. Find the ratio A to B of the areas of the similar triangles. So remember, step 1 is just like finding the ratio of the perimeters. Match up the sides and simplify. So 6/10, GCF is 2. I have 3/5. So this right here, this isn't the ratio of the areas. Before this can be the ratio of the areas, I have to square it. Because area is measured in square units, so that needs to be squared. So 3 squared is not 6. Please don't write 6. 3 squared is 9. And 5 squared, 5 times 5 is 25. So the ratio of the areas in these similar triangles is 9/25. That means if I know the area of this second one, I can multiply it by 9/25 and get the area of the first one. Hopefully that's making a little bit more sense. Alright, keep it going. For number 2, it says the base of triangle P is 8 meters. The base of triangle P is 8 meters. The base of triangle Q is 7 meters. what is the ratio of the area of P to Q? So this is basically the same thing as number 1, except there's words instead of a picture. If you wanted to draw a picture, you could. But I want to go from P to Q, and this is a base that's 8, and this is a base that's 7, and it says that they're similar, so I know that those are corresponding. They're both the base. So the ratio of their corresponding sides would be 8 to 7. That would be the ratio of their perimeters. To make it the ratio of the areas, I need to square that. So 8 times 8 is 64, and 7 times 7 is 49. I'm going to leave it right like this, because remember, when you write a ratio, it needs to be 2 numbers, right? So I want 2 numbers. So 64 over 49 is my answer. That means if I multiplied the area of triangle Q by 64 49ths, I would get the area of triangle P. Alright, here's another little math story. Isn't that a cute picture? I was trying to find a picture to put in the frame, and I saw that adorable little Yorkie. And I just pictured having that up on the wall in my house and people coming over and asking about it. I know. How cute. Anyway, you place a picture on a page in a photo album. I'm sure many of you have done this before. You have your page in the photo album, and then you try to center the other picture just right on the inside of it. Well, the page and the picture are similar rectangles. So this outer rectangle is similar to this inside rectangle. That means that the ratio of all their corresponding sides simplifies to the same thing. Letter A asks you, how many times greater is the area of the page than the area of the picture? So basically what I'm asking you for is, I'm asking you for the ratio of their areas. And remember, we learned how to find that. You take the ratio of their corresponding sides and you square it, right? So I want to know how many times greater the area is of the page than the picture. So I'm going to go from page to picture. So here's the page, that's 8, and here's the picture, that's 6. So again, order matters. It wants page and then picture. So for letter A, I would take the ratio of 8 to 6. I'm going to simplify that. GCF is 2, so this becomes 4/3. Right there I have the ratio of their perimeters. I want the ratio of their area, so I have to square it. If you didn't want to write the little 2, you could also just put another 4/3 next to it. That means 4/3 squared. You're taking 4/3 times 4/3, and 4 times 4 is 16, and 3 times 3 is 9. That would also work. But right here, this 16/9, that's your answer. That means that the area of the smaller, cute little picture is 16/9 of the area of the big rectangle, which is going to help us with letter B. Letter B says the area of the picture is 45 square inches. What is the area of the page? So I just said that all you have to do to figure out the area is multiply, right? So I know that the area of the picture is 45. All I have to do now is multiply that by my 16/9. Now, yes, you can put a 1 underneath here, and you can multiply across, and then you can simplify. I think cross-canceling will really help us out here. I see 45 and 9, and I know that 9 times 5 is 45. So I'm going to switch that up and make it a little easier for myself. 5 times 16 is 80, and 1 times 1 is 1, and 80 over 1 is just 80. So I'm going to write 80, and this is inches squared. So the area of the second picture would be 80 if the area of the first one is 45. And the last one, putting this all together, how does doubling, tripling, and or quadrupling the side lengths of a shape affect its area? Well, this isn't really proportional, right? The area one's not proportional because we're squaring it. So if you double, that means you're actually using the number 4 instead. So let's say that in your first shape, look back up here, this doubles, right? From 10 to 20 and from 5 to 10. And you see how I'm using 1/4 for that? So in a doubling, it's like saying the ratio of 1 to 2 squared, which would be 1/4. In a tripling relationship, it would look like that, which would be 1/9. And in a quadrupling relationship, it would look like that. So you're actually squaring each item. All right, you're done. Good work.